Hey Year 11s, this is the first lesson for exercise 6A drawing straight line graphs. This will be a fresh new topic that we'll be looking into, and this will be the first lesson. These notes can be found in Compass under the resources, or alternatively can be found in Microsoft Office 365 Teams Files tab. So exercise 6A drawing straight line graphs, we're going to be looking at linear graphs, and we know linear just means line or straight line. And with the help of understanding how linear graphs work, we're going to model certain situations in the real life world and get help from the almost different tools and options that we can get and grasp with linear graphs. For now, we're just going to look at the basics of how linear graphs work. So equations, so anything that has an equal sign in it, that are defined as linear relations, always generate straight line graphs. So when we say straight line graphs, if we were to graph an equation, the line will always be straight. A key component to this is when we look at a certain graph, the power that is corresponding with the pronumeral x, or whatever on the right side, the power has to be 1. If it's a squared or a cubed, or any power that's greater than 1, we're not dealing with linear graphs, okay? You won't see them pop up. For now, we're just going to consider the relation of y equals 1 plus 2x. This equation here is just a random equation. There's nothing abstract about it. All this is saying is, if we just look at the right hand side here, 1 plus 2x, if you give me an x value, any x value, there will be a corresponding y value to it. And with that x value that you substitute into there, you have to multiply that x value by 2 and then add 1 to it. In this case, it's written in a different way. It's 1 plus 2 times whatever x value you choose. But due to the commutative law, I'm pretty sure it's called, 1 plus 2 is the same as 2 plus 1, 3 plus 5 is the same as 5 plus 3, you can swap them around. Not the same as subtraction, so luckily we're just dealing with addition. So, we're going to plot this as a straight line. And we have created a table here, and we're just going to choose the x values 0, 1, 2, and 3. Now, we can technically choose any x value. You can choose negative numbers, decimal numbers, it doesn't matter. But to make it consistent and easy, let's just choose 0, 1, 2, and 3. So step 1, we're going to set up the table of values. So in other words, we're just going to do a simple straight substitution of x straight into this equation here. So when x is equal to 0, our y value is going to be 1 plus 2 times whatever x value we chose, in this case 0. So this is going to be equal to 1 plus, and you got to remember your body mass, you always do multiplication first. 2 times 0 is 0. So 1 plus 0 is equal to 1. So when x is equal to 0, our y value is going to be equal to 1. Next one is when x is equal to 1, our y value, and again this is a straight substitution, is going to be equal to 1 plus 2 times whatever number we chose, in this case it's 1. We always work out the multiplication first. So it's 1 plus 2 times 1, which is 2. So in this case, 1 plus 2 is equal to 3. So when x is equal to 1, our corresponding y value must be equal to 3. When x is equal to 2 and when x is equal to 3, we can easily work this out. Y is going to equal 1 plus 2 times, in this case, our x is equal to 2 now. Work out the multiplication first. So 1 plus 2 times 2 is 4. So in this case it's 5. Now, hopefully you can see the trend that's going on. As this number goes up by 1, the corresponding y value will go up by 2. And the number in front of that x is the indicator for that. Sorry about that. That number in front of x, the coefficient of x, this indicates what this is going to go up by. So we automatically know, as the x values go up by 1, we know that this value is going to be 7. but just to double check to make sure that this is the case, I'm going to put my head up there. When x is equal to 3, y is going to equal 1 plus 2 times 3. Work out what 2 times 3 is first. Is equal to 7. So we've got our x values, we've got our y values. The next thing we're going to do now is we're going to sketch this on this graph. Now, unfortunately, because of remote learning and remote teaching, these graphs, I would hand this out in class, but because we're doing this from home, you would have to rule up your own graphs. You don't have to draw each single square line for line. The main thing you will need to draw is a set of axes, the x-axis and the y-axis, and just making sure that the spacing that you do for them is spaced out evenly. Okay, you don't want to have 1 and then a 2 here and 3 somewhere down the line. Nice evenly spacing for the numbers. In this case, this spacing on the x-axis has been spaced for every second square, so every 2 squares is 1, every 2 squares is 2. But for the y-axis, it's spaced out by 1 for just each square. Okay, that's completely fine, provided that that scale for the y is consistent and the scale for the x is consistent. Okay. So step 2, we're going to draw labels, which we've done here, is this readily available, and scale a set of axes to cover all the values. We can see here that the lowest x value that we've determined is 0, and the highest is 3, which is here and here. And I'll put that in a red pen, just as a highlight. The lowest and the highest, and the lowest and the highest here. So when we sketch this, we have to make sure that we can see the x values, at least see the lowest and highest, and at least see the lowest and highest of the y's. So we're going to put the values in the table on the graph by marking a dot. I'm going to put my dots in, say, a lighter blue. So when x is equal to 0, our corresponding y value is going to equal 1. So when x is equal to 0, so on the x-axis, when x is equal to 0 here, our y value is going to equal 1. So that's right there. The next point is when x is equal to 1, y, or corresponding y value is going to equal 3. So when x is equal to 1, the y value is going to equal 3. And that's going to be there. When x goes up by 1 value, the corresponding y value goes up by 2. When x goes up by 1 value, the corresponding y value goes up by 2. Now, I'm purposely saying that when x goes up by this amount, y goes up by this amount, because these sets of characteristics, which we'll learn later on, have specific names, namely y-intercept, which is here, and gradient or slope or steepness, which is how much the graph is going up by as it goes along the x-axis. Okay, so we don't necessarily need to use that table that's over here to know the next one, because we know that that graph, when you generate it, every time it goes up by 1 on the x-axis, is going to go up by 2. In the y-axis. Okay, so we've got the values in the table and graph by marking with a dot. I've put a cross. You should put a dot, but just for demonstration sakes, I've put a cross here so you can clearly see where they are. Step 4, use a ruler to connect the dots that are hopefully in a straight line. If you have not constructed a straight line, you have done something wrong. Sometimes when students first see this, they can put a line that goes maybe possibly there, or they're off by 1, and it won't create a straight line from point to point. It will create straight lines per se, but it might go up and then tailor it a little bit off and then continue on. That's incorrect. Okay. So what we're going to do is we're going to create the straight line. Now I don't have necessarily a full option, so I'm going to try my best to create a straight line going across from here to there. You would use a ruler in your case. I also put an arrow on each line just to indicate that this graph goes on forever on both ends. Okay, we've mainly chosen these x values just to get a grasp of what the graph should look like at the start. But those are just numbers we ran chosen. Okay, technically this keeps on going on forever, this line. The last thing we need to do, and this includes the lesson 1, is we need to label the original equation. So label the line, sorry, with the original equation. So this line is y equals 1 plus 2x. You need to label the line. Every time you draw a straight line, you need to label the line, okay? Now there's a difference between a label and a title, okay? A label is something specifically that goes to a characteristic on the graph. In this case, this line has a label. For every y value we get, this y value is equal to whatever x value we choose to put in, times by 2, and then added 1 into it. Where a title, when we get to more of modeling and realistic approaches, the title will go below the graph, okay? So don't label the graph as your title. Don't put it here, put it next to the line, okay? It just keeps it consistent so I know what you're indicating. When we get into titling, that's where you will put a title down at the bottom, okay? And that concludes lesson 1 of 6A. Check your log sheet, see which questions you need to do. Make sure you correct them as you go along. I'll make sure that the work solutions are up on Compass. Stay safe, wash your hands, sneeze into your elbow. I feel like that's going to be my signature of leaving my videos. Take care, guys. I'll see you in the next video. Bye.